Question number 9, we are given that px square minus p plus 10 equals to 2 times p plus 2 times x has real solutions. That means its discriminant should be bigger than or equal to 0. But they are asking us that show that p cannot have a value between 1 and 2. So now we just don't have to find the value of p. We need to show the statement that they have claimed for us. We simplify everything, we take this term on the left. So now this is the term that is multiplied with x. So if I put it in the right sequence, I have px square minus 2 times p plus 2 times x plus 10 minus p. Now 10 minus p is constant, we name it c. This term is with x, so we call it b. So b will be minus 2 times p plus 2, and x square has a coefficient of p, so that is a. We plug the values in the discriminant. We have b square minus 4ac bigger than or equal to 0. So we put the value of b, we square it, minus 4 times the value of a times the value of c, all bigger than or equal to 0. When we expand this square, the square of negative 2 is 4, the square of p plus 2 is p plus 2 whole squared, minus 4 times p is 4p times 10 minus p bigger than or equal to 0. We keep the 4 same, expand this square, we have p square plus 4p plus 4 minus, we multiply 4p with the whole bracket, we have negative minus 40p, and negative times negative is plus 4p squared, all bigger than or equal to 0. We simplify the whole thing, then here we divide it with 8, so we have p square minus 3p plus 2 bigger than or equal to 0. If we split the middle term, we will have p square minus 2p minus p plus 2 bigger than or equal to 0. We factorize it, we will have two factors, p minus 2 times p minus 1 bigger than or equal to 0. Now if something is bigger than or equal to 0, we go for the roots. We take the minimum root would be 1 and the bigger root would be 2. So our range would be take values lesser than 1 or take values bigger than 2. So if this is my answer, that take values lesser than 1 or take values bigger than 2, that means the p values cannot be between 1 and 2. I have to choose either values lesser than 1 or choose values bigger than 2. I am not allowed to choose values between 1 and 2. This is what we had to show, and we did it. In question number 10, they say there is a linear line y equals to c minus 3x. It does not intersect the curve x times y equal to 3. So we need to merge the equation of line and curve and make an equation for the solution. So we say line is y equals to c minus 3x and the curve is xy equals to 3. If I find the value of y from the equation of curve, this x gets divided on both sides, so y is equals to 3 minus x. If I equate both sides, y from the line is equal to c minus 3x and y from the curve is equals to 3 upon x. Both y values should be same in order to agree or meet at a point. So if I multiply x on both sides, I will have x times c minus 3x equal to 3. Further simplify it, we have cx minus 3x squared equals to 3. 3 taken to the left, we will have negative 3x squared plus cx minus 3 equal to 0. So coefficient a is negative 3, coefficient b is c constant, and coefficient c is negative 3. They are asking us to find the value of c, and we know that if a line and curve does not intersect each other, that means they don't have real roots for this equation. If this equation does not have real roots, it means the discriminant should be less than 0. So we take discriminant, we put the values, we simplify it, we have c square minus 36 less than 0. We use the identity of difference of squares. We have c plus 6 times c minus 6 less than 0. That means our alpha root, first root is negative 6, the second root is positive 6. So if it is a case of less than 0, our root, our c value should lie between minus 6 and 6. That's the range of c. In question number 11, we have to do everything similar to question number 10. Just use discriminant bigger than 0 because they say it has intersection at two different points. In question number 12, they have the question 12 has a star, that means it should have a trick in it. So it says that k minus 6 times x square minus 8x plus k cuts the x-axis in 2 points and it has a minimum value. So find the value of k. we know that if it cuts x-axis in 2 points, that means discriminant should be bigger than 0. So we take a value as k minus 6, b value as negative 8, c value as k. We put them in b square minus 4ac and set that bigger than 0. So we simplify everything. In the end we get minus 4k square plus 24k plus 64 bigger than 0. The leading coefficient is minus 4, so we divide the whole inequality with minus 4. We have k square minus 6k minus 16, but this bigger than sign converts into less than because we have divided negative number. So we split the middle term in minus 8k and plus 2k. Our factors become k plus 2 and k minus 8 less than 0. Our smaller root becomes negative 2, the bigger root becomes positive 8. So k value should lie between minus 2 and 8. Now everything got solved and we did not see the trick where it was. They have given us an extra condition that says the equation has a minimum value. If it has a minimum value, that means the leading coefficient should be bigger than 0. We know that if a is positive, we have a graph like this. If a is negative, we have a graph concave downwards, right? So if we have a bigger than 0, the a value is k minus 6, so k minus 6 should be set bigger than 0. That means k should be bigger than 6. That means this range is not valid. We should not take values of k between minus 2 and 8. Rather, we should take the values of k from 6 to 8 because k should be bigger than 6. If you set k less than 6, you will not have a concave upward graph. You will not have a minimum value problem, right? So this is our final answer, and that part is the trick part. We're doing question number 13. It says y equals to 2x square plus px plus 16 is a curve, and that curve is below x-axis. That curve is negative when x value is between 2 and k. They are asking you to find the value of p and k. Again, it's a trick question. So this information that the curve is below x-axis when x is between 2 and k gives us a significant information that we know that if a curve is concave upward. Why do we know it is an upward curve? Because the leading coefficient is 2, which is positive, so we will have an upward curve. If I draw an upward curve, it will have negative values between the roots. That means 2 and k are the roots. So I would always, whenever I choose the inputs between 2 and x, I will have these negative values. So the graph will be below x-axis, right? So I'm using this information. This gives me two important points, that when you put x equal to 2, y will be 0 because x equals to 2 is one root, and when you put x is equals to k, y will be 0. These two are the roots, so this is my alpha and this is my beta value. And again from there, since x is between 2 and k, that means k should be bigger than 2, right? Otherwise it makes no sense. How can a number be between 2 and something that is lower than 2 if that comes after 2, right? So we use all this information. We take the first root, we say put x is equals to 2 in this equation and set y equal to 0 because x is equals to 2 is the root. So wherever there is x, we put 2. So we have 2 times 2 squared plus 2 times p plus 16 equal to 0. That's 8 plus 2p plus 16 equal to 0. 8 and 16 is 24. So 2p is equals to negative 24. That gives us p to be minus 12. Similarly, I got the value of p, so I will put it here. So my equation will become 2x square minus 12x. Px is minus 12x now, plus 16 equal to 0. My second root is x is equals to k. If I put x is equals to k, I will get y equal to 0. So wherever there is x, I put k and solve it further. So I got two factors, x minus 2 and k minus 2 and k minus 4 equal to 0. That means either k is equal to 2 or k is equals to 4. I have already mentioned that k should not be less than 2 or 2 exactly, because k comes after x and x is bigger than 2. So x cannot lie between 2 and 2, right? The only possible value for k should be 4. That if I put 4 here instead of k, I will have x between 2 and 4. So first root would be 2, the second would be 4. We got the value of k to be 4. Question number 14 is exactly like that, but it's a bit trick question and it is a bit lengthy as well. I will give you one sessional mark for whoever solved it correctly and sent the scanned version of it.